Statistics students, I'm going to finish part 3 of the final exam review to help you, and it's to supplement Mr. Trotman's video. And so this part 3 will cover problems 26 through the remainder of the assignment, which is 26 through 30. Okay, and so we're going to get started and share my document camera with you. And just as a reminder, some of the documents you want to have when you take your final is the important formulas handout, and you can find that in your study material page from your Math 1342 Canvas course. So it's helpful just to have this out. And also, it will also include the handout. This is testing the vocabulary for the binomial distribution and your cards and your sample space for the dies. And also, this PMC handout is also helpful. It's also would help to have the cards in color. That's as well. If you print it and it's in black and white, you can always get a Crayola or marker and color over that as well. Okay. And then remember, for the final exam, I do have like a template with lines built in to help you show your work. So remember, you want to be able to put formulas, substitutions, calculator commands, substitutions, kind of calculations, subtractions, to support your work. Okay? So we're going to pick up with problem number 26 with this recording. Okay. Right, so I'm going to so take a look at this problem. So it says calcium is the most abundant mineral in the human body and has several important functions. Most body calcium is stored in the bones and teeth, where it functions to support their structure. Recommended adequate intake RAI of calcium for adults ages 19 to 50 is 1,000 milligrams per day. A simple random sample of 18 adults with incomes below the poverty level gave the following daily calcium intakes. So we have data here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18, and it does say 18 adults. Estimate the mean calcium intake, mu, of all adults with incomes below the poverty level with a 95% confidence. Assume the population standard deviation is 188 milligrams, round to the 10th place. Okay, and so the issue I have with this problem is that when I put this data in, this assumption about the population standard deviation is very, very off. I think it shouldn't be 188, and I can show you and calculate something. So you can see here, I have inputted the data at 86, 633, 943, all the way down to data value 18, which is 809. So that means, okay. And when I apply stat calc to that, one variable stats, I have it here, stat calc, one variable stats, and I hit enter. Tell the calculator that I put the data in L1, leave the frequency list vacant. So I want you to take a look at this standard deviation. This is what we should be using, the S of X, not this one, even though we'll write it as the sigma, but we use this value S of X. And notice how it says 171.989. So really, if we're rounding this like to the nearest tenths, because data is counting numbers, so we round one decimal place beyond the data, that would be tenths. Really, this should be 171, well, 0.98, but if you round this to nearest tenths, this neighbor is 5 or more, it's 8, so you'll add 1 to the 9, which will make it 10, and you'll add 1 to the 1. So really, this should say 172, so there's an error here. And I want to note that the standard deviation should be reflective, and it should say, it should use 2. Should use, should say 172. So, and that's because sigma x equals 171.98953. So when you round that to nearest tenths, this neighbor is 8, 5 or more, so add 1 to 9. 9 plus 1 is 10, so add 1 to 1. So sig x is actually about 172. And that's what we should use. Okay. So, and I want to show you something in the book why I'm saying that. In your book, in your ebook, that for me, this is, I have one page 371 in section 7.2. So I'm not sure exactly if the pages are exactly the same, but it's in the section 7.2. I want you to notice here how we have a couple of problems. 13 and 14. And you see how they tell you to assume sigma standard deviation. See that? So it's okay to make an assumption, but I want to show you how they make an assumption and they're right on target. Notice here how this data is in the tenths place. So notice how they round this off to the hundredths place, 1 decimal more than how the data is. Notice how these are counting numbers like they are in our current problem. So notice how the sigma is rounded to nearest tenths, 1 decimal point more than the counting numbers. Okay, and we are seeing they are giving 92% confidence. This one's 99% confidence, and we are finding see the true mean GPA. And this problem says estimate the mean number of faculty. So we are finding the mean, which is mean value or confidence, right? We are finding confidence intervals. So we are going to be using this formula, like estimate the mean calcium intake, and the mu is the parameter. But we are finding this confidence interval. So I'm going to do this by hand first, and then I'll use calculator. But we are using this formula. So the mean minus critical value, critical z value, sigma divided by the square root of n. So remember we have 18, and we just agreed we're going to use 172 for sigma, and we're going to pull the mean from the calculator in a bit, and then we're going to talk about the critical value associated with 95% confidence. Okay, but going back to the assumption, show you something using this calculator. So if you look at 13, you can see your instructor has inputted the data. See 211, 621. So 211, 621, all the way to 324. We go to the first column, go all the way to the bottom. Okay, so I think we're here. 29 is 134, 356, 176. 539. Okay, so we have 32 data points. So this is for this first column. So I'm going to press stat, calc, one variable stats. And my data is, I put that in L1, so second one. Leave the frequency list vacant, calculate. And I want to show you something. So we're going to use this, we're finding standard deviation, but we're using this S of X, not this one. And so look at this, 165.099. So if we round that to nearest tenths, this neighbor is 5 or more. So we add 1 to 0, so 165.1. So you see that right here? That matches that. Go ahead. I can actually write that in here. So that's just to remind me to use the S of X in the calculator, not this one. And then I'm rounding to the tenths place. The neighbor is at least 5, so I'm going to add. So it's 165.1. Okay, and then I'm also going to show you using this example here. So I'll go to stat and go to the second L2 and it has 1.9. See, 1.9, 2.8. Okay, so there's 3.3, 1.9, 3.8 comes next. 2.7 comes next. 2.8, 2.1. So that's the stat. So I'm going to find the S of X for this. Stat. Calc. One variable stats. Sure. And for me, the data is in L2. So second, the number 2. This one, not the data. And you want to leave the frequency list vacant. Okay, so you see this here? S of X, not this one, but this one, S of X equals 0.61. Six, 1, 5, 8, 9, 3, 9, 8, 8. So if I round this to the nearest hundred, because see, this is tenths place. So hundreds would be tenth hundred. Look at the neighbors at 5 or more. Yep. So add 1 to that. So we're looking at 0.62. See that? So it's okay to make assumptions, but they should be kind of like right on target with that. So that's why I say that there was a mistake made here when they said assume standard deviation population is 188. So I have the data for this again. So you see 886, 633, and 18. 18 is 809. Okay, stat, calculate one variable stats, and my column is an L1, so my data is that, the frequency. And I'm using S of X, which is 171.9. These are my data is in counting numbers. So I'm going to round 1 decimal place beyond that. That's the rounding rule, which is tenths place. And the thing is, the neighbor is 5 or more. So I have to add 1 to that. 9 plus 1 is 10. So it's 172.0. That's a 10. So it just happens to be 0. Okay. Okay. So it's 172.0 is what we're using. So that's where the mistake was made on that. Okay. But now moving forward, we're out. Okay, let me first start to talk now next about the, so, okay, so we're gonna assume that the standard deviation is about, 172. We already know that n is 18. And, now let's talk about, the critical value. So it said 95% confidence. Okay, so now we have to find the sigma divided by 2. So from your quiz 3, this is your quiz 3 review guide. Remember that here's your formula, right, for the confidence level. So we already know n is 18. We already said sigma is going to be 172.0. And now we're trying to find this critical value, C alpha sub 2. So C right here, critical value, we use this second bars 3 inverse norm, 1 minus parenthesis 1 minus the percentage, R is 95, close the percentage divided by 2, mu is 0, sigma is 1. So we're going to use that. So for us, the percentage at 95% is 0.95. So move this over here twice. Okay, so then I go to second bars. And I want number 3, the inverse norm. So second bars, I want number 3 inverse norm, hit enter. And then the area is going to be 1, take away open parenthesis, 1, take away 0.95, close parenthesis, then divided by 2. So I'm getting that from your quiz number 3 study guide, and I'm getting that from right here. Oh, me use this calculator. We also do it on this calculator too. Second bars 3. Yeah, I was looking for this. Hopefully most of you have the calculator with this formula, see, but not all of them have that. So I'm going to type it in here first, but then I should be able to do this, but separate it with commas. So see, mu is 0 and 1. I have to do commas, 0 and comma 1. Let me do that here. So here for the area, it's 1 minus parenthesis 1 minus 0.95 close parenthesis divided by 2, and then 0 and 1. Whereas over here, I have to put that in, and then I can put comma, and then I have to put 0, comma, and then 1. And I think I'm good. Then over here, I just hit paste and enter. And so then I have 1.95. And then that's for the, this is a form of Z. So it's a Z-score, so I have to round to the nearest hundredths, tenths, hundredths. Is a neighbor 5 or more? Yes, it's a 9, so add to that. So it looks like it's going to be 1.96. Okay. Now, if you do this, I was going to see if I should be able to do this here. You see that works here. Yep. So here I have to put separate my commas and then the 0, 1. So I put this comma 0, comma 1. But it does give me the same thing as that. Then you round to hundreds. Now, I was also going to show you that if you do it on, let's see, by hand, this is on the calculator, this is on the TI-84, find the critical value. But if you find the critical value by hand, by using the table, so I'm going to draw a picture. And there's something. And I have here this like 2. So this would be, I believe, it was for a 95% confidence interval. So it's 1 minus 0.95 divided by 2. So it's this part. 1 minus 0.95 divided by 2. This part. So 1 minus 0.95 is 0.05, and divided by 2 is 0.025. Okay, and then we come over here and we do 1 minus that 0.025. So here. And 1 minus 0.025 is 0.975. And then we want to look for that area. Look for that area. 0.975 on the table. Standard normal table. 0. Put in the center 0.75. And I'm going to add a 0 to that because these areas are 4 decimal places. These scores are 2 decimal places, hundreds, but areas are 4 decimal. And when you look at up on the table, and I put in the middle because sometimes it's between 2 data values. So I think this one is exact. And I look for my Z, I'm looking for 0.975. Remember, we kind of already know it's 1.96, but you can see here. Nine, 6, 6. So see that? 0.9750. So it's 1.96. Okay. Everybody see that? 0.6. 0.970. Okay. And so we have RZ alpha divided by 2 is therefore 1.96. Sometimes it's in between 2 areas, 2 potential areas. And if the area you're looking for is in between 2 areas, then that's when you have to do this formula. Where you take the absolute value and you do your area minus the potential. Area. Absolute value. So sometimes your area is in between 2 possible areas. So then you take your area minus each potential and you do that twice. Take the absolute value. And then you find out which distance is smaller. And then you backtrack either to that area or that area, which one's smaller. And then when you backtrack, then you go with that Z value. Okay. Sometimes if the distances are equal, if you have equal distances, because sometimes that can happen, then you take the average, you add them up and divide by 2. You take the average of both potential Z values. Both potential Z values. You add this one, and then divide by 2. Take the average. So sometimes that can happen. And then also on your tables, I also did this. When you look at your standard normal tables, there should be in study materials, their study materials page, you should have a Z table that has these critical values where I've done a lot of I already figured these already. And so there's more. These are the ones that are very common. So they're not all on here, but these are the ones that are common critical values. So we just had 95, right? 95% confidence interval, right? That was what our problem said. So our problem said 95% confidence interval. So that is a pretty common one. And we did that, in our workbook and probably in our homework for probably section 7.1 or 7.2. But you can see 95, see they have plus or minus 1.96. Okay, so we're going to just use in the confidence interval, we just need to use the positive, and we use the 1.96, and that's what we found. We found this here using our table, and we found it here using our calculator. So that's for that. So then now, so 26. We're still on 26, but now we can use the formula. Now we can use this formula. Just mean minus z alpha divided by 2, sigma divided by square. This is positive. And now we know that it's 1.96 per c. Sigma, remember we said we were going to go with 172.0, which is just 172. Square root of 18. Positive 1.96. And now we just need the mean. So the mean, we're going to round that to the nearest 10. And we're going to do that like we did for the standard deviation. And that's due to the rounding rule. Which says one more decimal place. Than how data is presented. So in this problem, our data was presented as counting numbers. Counting numbers. And one decimal beyond counting numbers is tenths place. That was why we rounded the sigma to tenths place. So we go back to that calculator and have to calculate. This calculator, they have see 88663. So back to count one variable stats. Okay, so mean is 947. 947.3, and a lot of repeating 8. 1, 2, 3, 5. And we went around to use tenths. Look at the numbers, right? Is that 5 or more? Yes, it's 8. So add 1. So we're going to use 947.4. Okay, we're going to type that in. So we have 947.4 minus 147.4 0.96, open parentheses, 172, and I don't need to put 0.0, divided by second square root 18, but then I need to push this little arrow like that, and then I need to close that. And so it looks like we get 867.940054. And then on this side, it's identical except plus, so I can do a second copy and then just back space and then change the minus to a plus. So I do a second copy, which is inner, and then backspace to that minus sign and make it a plus, and then inner. And we get 1026.859946. And then we can round that off to the nearest tenths. So and then look at the image to the right. If that's 5 or more, this one's not. This one is. So this is 867. This is 1026. And I think we could also, if we put some units on that, I think we could maybe put milligrams units on that. Sometimes on the calculator, sometimes you'll see like an ordered pair. Sometimes you'll see it like that. An ordered pair. This is a confidence. Yeah. So we're at 95% confidence that the actual parameter will be within this interval. So we're 95% confident that the mean, it's a mu, mean parameter inside and the actual mean parameter will be inside this interval. I don't know. The original key, looks like the original key probably had a few errors, and so I'm looking at some old notes, see that had this old note from that. But I think it was because we probably weren't using the correct standard deviation. I think that was if we were maybe using 180 on that. Let's see. Yeah, so I think this is the other little extra, like a little extra answer key. See that matches this, matches that. But yeah, there's an error there. And I think that was because we're probably using the assumption of the one we can use. But I don't feel comfortable using that. You saw why, but I should make that work. Okay, it should be fine. And it might be that Mr. Trotman's video, if it's off, there was like one problem, I think, where maybe he didn't use all the data or something. That was a mistake made, just not all the data was typed in. Yeah, but this is a good general idea of how to do the problem. Now, I didn't do it on the calculator. This is all pretty much by hand. So let me see if we do this on the calculator. Okay. Yeah, so I do have a reference. If we do the calculator, there's a reference. Find confidence by T. So I think they use stat tab to test. So we know N is 18. And so and we already talked about how that's related to 6. So let's see. And let's go to the one calculator has that data. Go back to stats. And so yeah, that's the data, right? 886, 633. Okay. So let's go to stat, tab to test, go down to number 7, see interval. And see, we can go with data because we do have the data in there. So let's hit data instead of stats, let's go with data. And then sigma, we said we were going to use 172. And our data is in the L1. I think on the frequency, I think we leave it at 1. That's 1. Confidence level, you said it was 95%. 6, 7, 3, 1026.8. They say the mean is at 947.3. And so let's compare that to this. So see, here's the mean. See, there's the mean 947.38. We said 0.4. And then they got, okay, see, they got 867. Eight 67, 9, 10268. So it's pretty close, right? This is off by tenths. This would be the same. It's pretty close, but if it's a multiple choice test on the final, you'll be able to select the best. You should find something that's the best match on that. So even there's just a little variation, even to 10th place on one slide the confidence interval. Okay. So when you round to the nearest tenths, you're at 867.9, 1026. That's right. Okay. All right. Okay, so that's enough for this problem. Let's go to the next one. That was 26. Again, here were the steps for the calculator. So stats, tab to test. And we went with data. Data again. We would use stats if, just stats. We would use stats if you didn't have the data and they gave you more than that. So you just see, we had stat, tab to test for 7. If you wanted to use stats, then you'd have to put in, see, the sigma is 172. The mean, you have to find the mean, and we said the mean was 947.4. And this 18, confidence is 95. So that would be if you go with stats, you'd be putting something like that. Let's see. Down to the tens. And now this is more accurate because when you do that, now that matches what we did here by hand. So when I do that, it matches what we did by hand. Okay. All right. Sigma is 172. Means 9, and was 18. Confidence level. Okay. All right, so now let's go on to now to 14 and 15, page 14. This is an instructor at Arizona State University as a random sample of 8 students to record their study times in the beginning calculus courses. She then made a table for total hours studied, which is X, over 2 weeks, and test scores. At the end of 2 weeks, the results are well. Compute the least square regression equation for predicting test Y scores from the total study X. Okay. So they don't want us to plug in a value, but they want the equation. So if we do regression, here's the equation for that. Y prime equals A plus BX regression line if it can be done. This is from quiz 3. And what we do is we also look at the absolute value R. You want to see if that's greater than your PPMC table 1 value. And R is the correlation coefficient. So we had a problem here on the study guide. We have to compute the correlation coefficient. We also make use of degrees of freedom, n-2. So n stands for your number of data values, like your X data values. So in this case, 1, 2, 3, 4, 5, 6, 7, 8. So in this 8, so 8 minus 2 degrees of freedom is 6. And when we look at our PPMC table, reject H sub not the null. Population value is equal to 0. That's your row. If the absolute value of R is greater than the value given in the table, values are for a 2-tailed test, degrees of freedom minus 2. So for us, we have 8 minus 2, which was 6. 6. And then we have these values for alphas. I'll write those down. And these are So when we have degrees of freedom 6, we have 0.707 and 0. And then we just need to find that R. Sometimes in the problems you were given, like the quiz, in your homework, I noticed that they would give you the R. If they don't give you your R, you do have to find your R. So let's go to we have to find R. What number is that? Let's see. Remember when we did this problem here? We had to find R, the correlation coefficient. And we found R. So we did, we put our data, we have to put our data in the computer. So calculator X and Y. So we're gonna have to do that, put our data in. And then use a linear regression test, put X data, put Y data. Okay, press that, tab to test, and go to linear regression T or alpha F. Enter. Okay, let me write that down. I'll put L1 here. L2. Y'all can start entering the data. Start entering. And press stat. Tab to test. To F, which is linear regression T, or to get there faster as a shortcut, alpha, and on top of cosine. Yeah, so that's the shortcut. Otherwise, you have to go all the way down to listen alphabetic through numbers like 0 through 9, 0 through 9, and 1 through 9, 0, and then the letters A till you get to F. So this is a shortcut, alpha F. But you want that linear regression T test. And identify data locations correctly in the X and Y. Frequency should be 1. And then on your row, this is your row, like a P, you want not equal to 0. You don't want the less than or the greater than. The less than is left tail, the greater than is right tail. Because this, remember, it's two-tailed. And for regression equation, hit bars and tab to Y bars, one function twice. Tab to calculate. I think Gauss is going to be ready set because we already did this. Remember, we had hit done when we did that problem number 6. So I think you'll be fine. We'll get to that point here. Okay, so I'm going to enter my data. Okay, so clear, top clear, top clear. Okay, so 10, 15, 12, 20, 8, 16, 14, 22. 92 for the Y's, 81, 84, 74, 85, 80, 84. And you want it to, you don't want it to be mismatched, or you want the same amount of data. If one is longer than the other, the column, the amount of data, if it's a mismatch, area won't come out with different parent. And then you want to go to stat, tab to test. So I'm gonna look, I want to find the R value so I can use it in this table. And let's see. So we want to see if we want to do linear regression, then we want to find the actual equation for A and for B on the calculator. That's from the TI-84. That's if we need to do regression. So tab to test, and then you want to go to F, which is alpha cosine. And X is L1, Y is L2. Frequency, this is 1, and then you want the not equal to 0 row, not equal to 0 high. This is left tail, right tail. This is 2 tails, not 2 tail. See, this is already there. See, regression Y1 is already there because we did 6 already. If it weren't, then you would have to learn the instructions on 6. Page 6 of this little, just like the answer key, you have to go and do these steps. Go to catalog, which is found on 0. So press the second key, go to catalog, which is found on 0. Turn the diagnostic on, so it's alphabetical, and turn it on. And then you would proceed with what we're doing. It's linear regression here. So we already have the Y1, so we're good. Calculate. Because if not, then you'd have to go a few more steps, go to the bars, Y bars, one function, enter, and then you have that there. And then calculate. And we want to look, see there's your Y equals 8 plus BX. And these are free to 6. And we might see here's A and then B. We might need to go back and get those, but we want to make sure that we need to do regression. So I'm looking for not R squared, but I'm looking for R. And it turns out that R is equal to, which is the correlation coefficient, is 0.7. So it's negative, but we're going to take the absolute value of its absolute value. Negative 0.77489999. How many nines is that? 4. And then 7. So when you take the absolute value of that, and since these are rounded to 3, I can round it to 3 decimal places. 1, 2, 3. Look at the numbers to the right. I have 5 of them. Yes, I have 1. So R is about negative 0.775. Now I'm going to take the absolute value of it. Absolute value of negative 0.775 is 0.775. And so you want it is the absolute R greater than the PPMC value? So we have that as absolute value of that is 0.775, and is it bigger than these? So it's bigger than this one, alpha equals 0.05. It's not bigger than this one. When they don't tell you the alpha value, it's safe to assume that you use alpha 0.05. So it's safe to assume that you want to use alpha equals 0.05 unless otherwise specified. So since they didn't say anything, then we want to use the alpha 0.5. So the 0.775 is bigger than 0.707. 77, it's almost 78. It's like 70 cents or 71 cents. So this is like 71 cents. This is like 78 cents. So this is, I would say this is true. So I would say do regression. Fine. Regression. Fine. And if it's multiple choice, you can look at your choices. If they had a choice that said none, like a choice that said don't do regression, then I would go ahead and do the check and make sure that you can do it. But if they all have equations, then that means that that this assumption has been done. You can use regression. Then you just want to find the A and B, plug it into your equation. So oftentimes people do find the A and B, but they plug it in the wrong place or they choose the wrong equation. So you want to be real careful because it's y prime plus y prime equals a plus bx. So you get those from the calculator. So I think there's A and B. So A is 94.866987, and B is negative 0.856057. And then as far as rounding goes, it doesn't tell us what to round, but if it's multiple choice, you can look to see what they round to. So I would say, I guess we'd be okay to round to three. These are 3 decimal places. So we round it to 3 decimal places. I guess it'd be okay. A would be 94.8123. This neighbor is 5 or more, so add 94.867. And then it's minus B minus, let's see, tenths, hundreds, thousands. Look at the neighbors at 5 or more. Yes, so I add 1. So minus 8.6 respect to x because that's B. Okay. And also, if you change it up a little bit, it would be okay to say y primes if you say negative 0.846x plus 9 to 1.867, because that would also be okay. I'm going to recognize that as well. But we're working out y prime equals bx. That's why I kind of had it written like this. But see what the little answer key says for the 27. There's the little answer cases. Here's the correlation coefficient. So it looks like we got about the same thing. See.
I think this says that no regression inclusion was advised on the original handout. That would have been if they were using this one. But I think we're supposed to use, I think if it's not given, we're supposed to use alpha 0.05. Usually the ones you did on your homework and Alex and on the quiz, they told you right what alpha to use, remember? And they also gave you R. We didn't have to figure out R. They gave us R and then they told us what alpha. So this one, you know, we have to find our R, which is more practice for number 6. And then sometimes, you know, it works for both alphas, but in this case, it's true for this one and false for this one. Because the absolute value R is 0.775, which is about 78 cents. It is bigger than 71 cents, but it's not bigger than 83 cents. So it's true for this alpha, but false for this one. So this one would say don't, if you're going to use this alpha, it would say don't do regression if you're going to use this alpha. But if you're going to use this alpha, then do regression. So since they're telling us to find regression, and like if it were multiple choice, if one of the choices was not, don't find, no regression can be done. If they're all equations, then you want to go for it and find out what A and B is. Okay. And so that's what I use. I use this F linear regression is what I use for that. Okay, that's what I use for that. All right. Okay. Let me see if there's anything. This would have been in 10.2. But, you know, in 10, if you do it by hand, look at that's really long. We usually use a calculator, but if you find R by hand, and some of the videos in Alex might have been telling you to do it by hand, but we use the calculator. And then look at the regression equation. Look how you figure out A and B. A lot of multiplication and division and summations. So I just use the calculator, but you know, you can do it by hand. It's formulas, and that's probably what Alex was showing. But in my videos, I was talking about using the calculator. We do have permission to do that. When I was in school, taking stat classes that you could say you had to do everything by hand. And we had to memorize, you know, the formulas. Now it's so much easier. Calculator. You can use your notes. We weren't allowed to use our notes. We have to memorize it. It could be done. All right. Okay, now let's finish up 28, 29, 30. So for these, I also saw something else. I was going to go back to this. I saw something else here in the notes here. The formula. I like this here. A is the intercept. B is the slope. I'm going to put that in here like that. So B is your slope. And this A is your intercept, which is where the line crosses. I was gonna say that this is true for alpha. Should note that. Maybe here, click false for alpha equal 0.01. And if you ask the value R equals to the PPC table value, we have 0.707. Alpha point of 1 is 8, so that one's false. But alpha equals to 0.25. Since alpha was not given in the problem. And so since alpha wasn't given the problem, and they didn't say that maybe there's no possible regression, then we assume that they want us to do regression, they want us to find the line. So we assume that we used alpha equals 0.05 if it wasn't given. Maybe they just forgot. So we used alpha equals 0.05, not alpha equals 0.01. Okay. No, you know what? The other thing I'm noticing is we used linear regression tests. I think we also could have used. I think we used the linear regression test. I think we also, because we got an A and B out of that. I think we also could have used this 8 for linear regression as well. Let me do that and make sure we get the same A and B. So we use this. Yeah, we were using that because we were using that because, okay, we were using this because we didn't have R. And we were trying to come up with R. And that's why we did that. But then it gave us the A and B. But now, let me make sure that is it. Yeah, so now let me go to a stat. Tab to calc. Press 8. Linear regression ABX. Okay, does the A look the same? Okay, here's your A. 94.866, and then the B is the same. Yep, negative. Yeah, so we get the same A and B, and then there's R. It does give us R. So we could have found R as well. So there's 2 ways to find R and A and B. There's 2. So you can use the linear regression, and then you can use the 8 as well. So let me write those down somewhere. So we went to stat, tab to calculate, and we went to press 8. The reason we did that is for linear regression A plus BX. Enter. And then you have to do an X less. So tell them where your data is at for L1 and L2. And this one says you leave the frequency. This one, interesting, you leave it blank. Vacant. Try it again. So stat, calc, 8. It works on full calculator. Let me go back to this calculator. See, remember how it's because I might have slightly different calculators, right? Programming. Stat, tab to calculate. Number 8. Yeah, there's your, that one has the X less. So there's two types of calculators depending on the program. This one you do have to put in where your data is for L1, it's for L2, and do leave this frequency one blank on this one. Whereas remember on this one, remember we had to put in up for that. Yep. Here's your number 4. So yeah. Let me see what happens if I do the other one on this. If I do the other one, this one, stat, test, linear regression, so alpha, sum. Yeah, this one you have to put a 2 and then test 2 tell tests and what has to be there. Okay, and then this one you have to scroll down. Right? So there are 2 tests to do. All right. That was good. It's gonna help on this, these problems, these are new problems. You can have one on the final, but it's gonna help us with this right. So a few years ago, they changed the setup for the hypothesis setup to these for two-tailed, right-tailed, and left-tailed to these up above. But about 5 years prior to that, if you look at also antiquated journals, they will have their hypothesis set up this way because this is old school conservative, how it always used to be done up until about a few years ago, 5 years ago or so. They changed that. Now we write it up this way. At least Alex honors that. So what happens when we're setting these hypotheses up? The vocabulary. See all this vocabulary here? See this vocabulary up here? The vocabulary is helpful because you need the inequality. So even though these are not, this is not related to binomial distributions, but what we need is the vocabulary and the inequality. So exactly is still equal. Less than, fewer than is still less than. Less than or equal to is still less than or equal to, at most, no more than a maximum. Greater than or more than is still, this is the inequality for that. Greater than or equal to, that's the inequality for greater than or equal to, at least, no less than. Same thing here. Same thing here. Same thing here. All of these vocabulary words are for less than. All these vocabulary words are for greater than. So you still need the vocabulary and the inequality. Because whatever the inequality is, you go down to the bottom and you look for, see, you look for the either the equation or the inequality. You look for that here. And then whichever of these two tail, right tail, left tail, then when you write it up based on these. And the first time you look for the vocabulary and you find inequality, that's going to be your claim. So you want to put a star on that because if you want to keep an eye on the claim, you're doing hypothesis testing. Okay. And then you're able to identify. So see how these right here, like this is right tail. Yeah, so it's based on H1. So H1, this is right tail because this is pointing to the right. This H1 is left tail, so it's pointing to the left. So it's two-tailed. So based on that, H1 alternative hypothesis. Okay. So we look at the first problem. It says, and I think we can write the claims down here. Write these down here. I'm gonna see these. I'm gonna copy these bottom, these on top. So I'm gonna do that. The parameters can change, like these are mu, but the parameters can change. Like to sigma. This is mu for mean, but it could change to standard deviation, like to sigma. So the parameters can change, but our parameter is mu. Okay. And then so you also bottom. Parts at the bottom. Okay. All right. So let's see. So when testing the null hypothesis, and the null is H sub 0. So these H1 is the alternative. Null, alternative. Null, alternative. When testing the null hypothesis, the assumption is that the mean or the proportion or the standard deviation, those are parameters. So mean is mu, standard deviation is sigma, proportion is the letter rho, it looks like a P, is equal to a given specific value. When conducting a study, the researcher is looking for evidence to support a claim that's stated as the alternative hypothesis. So we look at number 28, write the claim as a mathematical sentence, state the null hypothesis and alternative hypothesis, and identify which represents the claim by writing a claim or a star by it. The school publicizes that the proportion. So here's that's the parameter. It's rho, which is a parameter. of its students who are involved in at least one extracurricular activity is 61%. So is your vocabulary. And it's not an inequality, but it's an equal sign. So if I look for is versus is equal to, so it's an equal sign, okay? So I want is 61. That's percent, 61%. So I look at the bottom, please, and I see that is, let me highlight this. I see that right here. Not here, not here, not here, here, but here. So then I'm going to write this down here. And then that's going to change to this. Oh, which happens to be identical. It's identical. This is the only one that's identical. These are slightly different. See, H0. Here, this changes to equal. Over here, this greater equal to changes to equal. But these are identical. And so we want to use that, but now we want to substitute. So we want to use this. And substitute our values. Okay, which would be 61. So you want to say H sub 0. Oh, and then the star, when you put the star on the is, you put this is your claim. That's your claim. So that's your, so you have mu, the parameter, is equal to k. For UK is 61. H sub 1, mu is not 2, 6. And oh, you know what? For us, actually, we're not doing mean row. It's a parameter. It's actually not mean. It's supposed to be. So here, these are all mean, mu, but we actually changed it to proportion. So a parameter. So it's a proportion, which is like the row, and it's not a mean. It's not mu. So then I need to change this here. I had to change the means to P for rows. It's like a P. So remember, it's a Greek letter of the alphabet. Remember we talked about the Greek letters of the alphabet. You see this row? Yes, row. It's a pronoun. That's for proportion. So row is a Greek letter for proportion. And then this would be our answer. So it's like this. It's like this first one, basically. Okay. All right. Now, a car dealership announces that the mean. So now this is the another parameter. this is mu, which is the Greek letter. Mu. So it's the Greek alphabet, and there's M, U, M. U. For an oil change is less than 15 minutes. Okay, so that's your vocabulary. Less than 15 minutes. Okay, so less than, right here, see, less than, and you want the inequality. This is inequality. Less than, and you want the inequality. It's not a binomial distribution, so you don't want that command or anything like that, but you need the vocabulary less than, and you need the inequality. Because now you need to come down here and you need to look for the inequality. See it right here? You need that. So I'm going to write this down, and then it's going to turn into this. And then I just changed my K's to 15 because it was 15 minutes. I start off with less than 15. Okay, so I need that. Less than 15, so I need that. Okay, then I look at my choices on the bottom. I see this less than. I want to go with this. And my claim is that it's less than 15 minutes. So this is my claim. That. But then now I have to change it. They remember said 5 years ago they changed it. They write it like this now. So now I have to change to this. Now I have to use this, and I have to substitute. K, which was 15. So also over here on this problem, not only we have to substitute our value for K, which was 61, but also we have to change mu to rho, mu to rho. It's like a P. We have to change this. So I have to change that to here, 2 rows, which is like a P. And K's were 61. So in our problem here, we get to stay with mu. See, it's mean. Over here was proportion. This is mean, so it'll stay mean. So use this as substitute value K, and mu stays, doesn't change to a row like up. So we have, oh, and then the claim is, this is our claim. The star is on claim. It's less than. This is mu is equal to 15. H1 mu is less than 15. This is our claim. That's it. So I check these. 62, 28. Yep. Oh, I forgot left tail, right tail, or true tail. I forgot that. Okay, I forgot to talk about this. Is it left tail, right tail, true tail? Let's see. Okay, I need to go back to these. So these first, oops, these first here. This is here. These are two-tailed. This one's right-tailed. This one's left-tailed. So I'll get something here. Right. So you see how that, look at the alternative left, alternative right, and this is considered two-tailed. So this one was reflective of this. This is two-tailed. Number 29, mu less than, so this is mu less than. So this is left-tailed. Okay, and the last one, 30, a company advertises at the mean. So again, the parameter. Sometimes it's a mean, sometimes it's a row portion, and then sometimes it's a sigma, sometimes it's a standard deviation, which is a sigma. So the parameters, these are parameters. Sometimes, see, it's a mean sometimes it's a proportion, which is rho. So this is mu. This is rho. And then this is sigma for standard deviation. And sigma is the Greek letter. See? Sigma. Okay, it's capital. Sigma for standard deviation. All right, so company advertises that the mean new life for its furnaces is more than 18 years. Okay, so you gotta look for more than vocabulary. Not this one, this is no more than, just more than. So it's right here, more than, and see that? More than, and see that inequality? Sometimes if you don't see it down here, then you do have to look here. These are other vocabulary as well. Okay, but we see more than, and see that right there. Okay. More than 18. Okay, so then you look for that down here, more than. See that right here? You always look at the bottom first and see this. So we'll write this down, but then in our answer, we'll put this. And then the mean is okay, it's mu, but we do have to change the K to 18s. And it is going to be right-tailed. And then the claim is on the more than 18. So it's the claim is on this, is our claim. Oops. This, and it changes to this. Changes to this. Substitute. Let me just go back over here. Left tail on this one. And do two tails.
Oh. All right, class. So that concludes this
Final exam, the study guide. So I really hope this was for the final and it's supplementing Mr. Trotman's study guide as well. Okay. Good luck on finals. Okay, mine on stats. Take care.